So let's continue to make these problems slightly more complicated. But again, we want to look for something that looks like a composition. And here I see in the antiderivative of x times the square root of the quantity x squared minus 1 dx, I see x squared minus 1 inside of this square root. So that's what I'm going to pick to be my u. So we'll let u equals x squared minus 1. The derivative of that, du dx, is 2x. And I must be on the right track because once I let u be everything under the square root, I see an x and a dx out here. And by multiplying both sides by dx, I get du equals 2x dx. Almost the same thing as the x dx. The only difference is it doesn't have this 2 in here, so let me just divide by 2. So we get 1/2 du is equal to x dx. So we'll put that in place of x and dx. In place of the x squared minus 1, we'll put u. So I'm going to go ahead and put the x next to the dx. So this piece is going to become 1/2 du. And all of this will just become square root of u. So I'll put those pieces in. Now I need to take the antiderivative of square root of u times 1/2 du. I'm going to pull out that 1/2 in front because it's a constant. So I need to do 1/2 times the antiderivative of u to the 1/2 du, where I've written the square root of u as u to the 1/2 because I know I'm going to need to use the power rule. So to use that power rule, I need to add 1 to the power and then divide by that power. So when I add 1 to the power, I get 3/2. And now I'm going to divide by 3/2. So 1/2 times u to the 3/2 divided by 3/2 plus c. And 2 times 3/2 is going to leave us with 1/3 u to the 3/2 plus c. So we've done my antiderivative, but now I need to put the u back in. So when I put the u back in, since it's to the 3/2, that's the same as the square root of a third power. So we get 1/3 square root of the quantity x squared minus 1 cubed plus c. Remember, this is the square root is a 1/2 power, and when you cube that, that's what gives us the 3/2.